You're good.
All right. Ready? Okay.
Yep.
Okay. Group 14 meeting quiz. Hmm. 18 questions. What?
You know.
Yeah.
All right.
Okay. Do you want me to read?
If you feel so inclined to.
I will read. Okay. So question 1 and 2 are the ones that you guys know those that we do on our own. Okay. So we need the following data sets right there. Please remember to round to 3 decimal places. Da 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 da. Okay. In an, I don't know how you guys say that, ANOVA
Yeah.
hypothesis test, we reject the hypothesis when there is sufficient evidence to indicate at least one mean is different from the others. True or false?
Is that false?
I think it's true.
I was going to say true.
Yes, I think it's true.
I think it's true.
I think it's true too.
Yeah, I always get them wrong. It's okay.
No, you do not.
No. That's yeah, it just has to have one or more of the means different from the others. For the
Okay. Yeah, that makes more sense.
And every time that we have sufficient evidence, then that means that we reject the null.
Reject. Yeah. Okay.
The null. Okay. All right. Question 4. What requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply. So, I have it right here. It says we can conduct ANOVA testing when the following 3 requirements are satisfied. 1, the data comes from a simple random sample. 2, the data are normally distributed within each group. So that's the second one.
Yep.
And then the third, the variance is constant. It doesn't say equal.
No, it says constant. You're right.
So I think it's just the second one. What do you guys think?
And I did read it somewhere saying that variances are equal in each group.
Yeah, me too. I remember equal. That equal.
Let me see something here. Because it says the rule is if the largest variance is not 4 times the smallest variance, then we will conclude that the variances are equal.
There you go.
So we think just those last 2.
Yeah.
All right. You agree, Kathleen?
Well, yeah, but now I'm starting to think, I thought I read, it's probably on something else that something has to be positive and it can't be negative. I can't remember, but no, I think that's right. We'll try that. Bottom 2. Okay, so question 5, to check if each group is normally distributed, do the following. So the first one, construct a scatter plot of data in each group. Or 2, construct a histogram of all the data. Or 3, conduct a QQ plot for each group.
You need to do.
I would say a QQ plot.
QQ plot, yeah.
Yeah, I think that's right, is the QQ plot. That's what I'd say.
Yeah.
Could you do a histogram, though? I don't know. I don't remember. What do you guys think? I think that, well, I know it's a QQ plot, but I don't remember if it's
It doesn't say for histogram.
Okay.
I didn't read anything. I mean, that doesn't mean that it can't, but I don't remember reading anything about a histogram.
Well, this review says It just mentions a QQ plot. So,
Yeah.
okay. Everybody good with that?
This one.
Yeah.
Okay. So question 6.
And
I'll go.
Kathleen,
Uh-huh.
I found where it says the variants are equal for each group.
Ah. Okay.
It
All
states
right.
that right there, yeah.
Right there.
So yeah,
Okay.
we're good.
Okay. Question 6. We assume the variance in each group is the same if the following happens. So the first one, the sample variance for each group is smaller than the sample mean. 2 is the largest variance is less than 4 times the smallest variance. 3, the largest sample mean is less than 2 times the smallest sample mean, or each group has the same sample size.
I think it's the second one.
We assume the variance in each group is the same if the largest is less than 4 times the smallest.
I think it's the second one. Let me find them.
The largest variance is less than 4 times the smallest variance.
Yeah, I agree.
Yeah.
Because this right on the review, it says this is satisfied when the largest variance is not more than 4 times the smallest variance.
Mm-hmm. And it agrees with this since it is less than 4 times.
Yeah, I guess that's true. It's just different wording.
Mm-hmm.
Yeah.
Okay.
It still kind of means the same thing.
Yeah, they just try to be tricks.
Yeah.
Tricksy.
No, that is tricky.
Yeah, okay. All right. Question 7. An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1 to 2, 1 to 3, and 2 to 3. How many pairs are there when there are 4 samples? Well,
I want to say it's
so 1, 2, 3, 4, 5. I think it's 6. What do you guys think? Because all I do is I write down like 4 things because I know this was like in the homework or something.
Yeah, I think you're right. It's 6.
Because then you got to just count how many times you have to pair up each one.
Right, exactly.
So 1, 2, 3, 4, 5. Yeah, I think it's 6. What do you guys think?
How did you know that? What did you?
So say like my 4 fingers. Say you have to pair 1, 2, 3, 4, 5, 6. Does that make sense?
Oh,
Yeah.
gosh, yeah.
I just write 4 lines down on a piece of paper. Yeah, and then count.
Still.
You can use your hand, Crystal. That's okay. Okay, so the next one, let's see. Okay, the data in soccer shoes was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target. So smaller numbers are more accurate. Use the scenario above to answer the next 5 questions. Okay, so we have to open this and then use our little thing.
Okay.
We have to use the quantitative inferential law.
Yeah, and the ANOVA thing test.
Yes.
Yes. So now we have to cut and paste, cut and paste, cut and paste. Let's see. And it takes my computer a second. I should have tried opening this before.
A, B, C, D, E.
What in the world is that? Let's see. Okay, there we are. Enable editing. Okay. Copy. So Mackenzie, do you know what to do?
Yep.
Okay. I actually understand this chapter, or this, I think, pretty good, which is good.
Thank you for checking on.
But you said you kind of had a hard time with some of it.
Well, it's just like it's just more technical, I think. Like I feel like I was
Yeah.
just dumb about it, you know? About
Oh.
like copying and pasting and putting things in a certain order, you know.
Well, that's hard. Yeah, that can get really confusing.
So I don't know. That was annoying.
Okay,
Mhm.
I'm confused with the soccer shoes. I open it up and it says footwear accuracy and then comments. But in the description, it said that there are 5 types of shoes labeled A, B, C, D, and E. Am I missing
I haven't
something?
got.
Yeah,
I haven't got that far
but
yet.
I think we should just focus on from A through E.
Oh, I know what you're. Okay.
I don't know. What do you think?
Oh.
I haven't got that far. I'm copying and pasting.
It's all good. Okay.
I guess I thought we'd be putting them in columns. Weird. Okay, never mind.
I think we can
Yeah.
we can use socks.
We can use what?
Like adding socks. Well,
Because that would be variable 6, right?
So we are going
A, B, C, D, E. Yeah, that would be 6.
Oh yeah, it says 6 groups.
It does say 6 groups and socks.
Okay, you're right. You're right.
So all we do is just copy all of the A's and put them into
Uh-huh.
variable 1 and so forth.
Yes. Paste. Okay. Last one. Socks. Okay. Copy. Okay, something is really strange. I lost. What in the world would happen with that?
No.
Something's going on funny here. Huh, that's really strange. Let's see. My computer just did something really weird on this thing, so I don't know if it's gonna give me the right answer. Let's see. Copy. No, that's not right. Oh, there we go. Now that might work. Let's see. What in the world? I'm having a hard time with something here. Okay, A, B, C, D, E. Sorry, I talked to myself, you guys.
It's all good.
Are you guys there yet? Are you done?
Yes.
You're waiting for me? I'm sorry. I had to redo this one over because something messed up a lot in my, something strange. All right, I think I got it now. Okay. All right, oh, let me go back to the question, I guess, huh? Okay. What is the minimum or the smallest variance for the 6 groups? Round to the 3 decimal places.
I got 27.208.
Yep.
Yep. That would be right, I think.
Mhm.
27.208. Okay. Okay, question 9. What is the largest variance for the groups? That would be the 53,
158. Yeah.
353.158. Okay. 53.158. Okay. All right. Question 10. The test for equal variances is satisfied for these data.
Yeah, I have to ask a dumb question on that. What does that mean again?
The what?
Question 10. What does that kind of mean?
Oh, what does question 10 mean?
So the test for equal variances is satisfied for these data.
Is
So
that when you divide each of them?
Well, we have to do test for equal variances.
Nabiri,
Oh, what?
you can say it. Keep going, keep going.
Oh, sorry, I'm just blabbing.
I'm just laughing.
It says the variance is constant. It's satisfied when the largest variance is not more than 4 times the smallest.
Yeah.
Oh, yeah, okay.
Yeah.
Okay.
And in a video,
So,
So you have to take the largest and you have to make sure that it's not 4 times that smallest number.
which it's not.
Right.
Because that would
So-
the highest it would have to go up to is like 80 something or 90, right?
Right. 20.
So the test for equal variances is satisfied. True or false? True?
Mm-hmm.
But actually, if you multiply the 27.208 by
Mhm.
4, it has to be like 108.
Oh, okay.
So we're good.
Okay. Question 11. Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots. Do you guys each want to take one, or do we have to all do it separately?
We can take 2. Like we can make 2 each of us.
Okay. Do you guys want to split them up?
Sure.
Mm-hmm.
I'm sorry,
Okay.
what am I doing?
We're splitting up to do a QQ plot. So I'll take the first one. Who wants to do the second one?
I think there's.
I'll do 5 and 6.
Okay.
Okay, so who's doing 2, 3, and 4?
2, 3, 4. I can do like 3 and 4.
Or okay, Crystal, are you doing 3?
I'll do 2 because Raquel's doing
Oh, 2. Okay, sorry. Yeah. Okay.
How do you even make a QQ plot? See, this is where I get confused on too.
Oh, you have to go to the quantitative descriptive statistics
Excel.
Excel thing.
Oh, okay.
You know where you go to make the histogram? Do you remember that one?
You can make a QQ plot on the second
Tab.
sheet or
Yeah.
tab, whatever you want to call it.
Here, let me just try and get there and see.
I'm doing 2, right?
Right.
Yeah.
Yeah, you're doing 2.
Sure.
Sorry, guys. I don't mean to throw you off.
No, you're all good.
Mm-hmm.
No. Mine kind of looks like a snake. I don't think it's equal.
You have to sort the data. Once you plug in all the variables, you need to sort the data
What do you mean?
to the smallest to the largest. So when you
Oh, you just
You can't just plug it in. You have to arrange it.
Oh. So you have to type them in the smallest to the largest?
No, you can use the sort filter,
Mhm.
and that should do it for you.
35 through 33. Did that work?
Can someone help me try and find the file? What's it called again?
Quantitative descriptive statistics.
Okay. Oh yeah, that one.
In our reading, it's the one from the first.
Right.
That
That old guy.
old guy. That's funny.
Well,
Okay, so now tell me what you said about we have to do it from smallest to largest.
Yeah, so if you go up to Data tab at the top,
Yeah.
then you click on Sort. If you click Sort, it'll give you like a listing of how you want to sort it. It should default from smallest to largest. So you just click OK, and when you do that, it should automatically sort it.
Oh my gosh. Yeah, it did. Wow. You're so smart.
I know. Yes.
Okay, mine looks much better now. Okay. It looks good now.
Mhm.
Okay, did you guys get yours?
I did. Yeah.
Yeah, but it's not putting it in order. It's just rando. So how did you say you did that? Because I kind of cut out.
Oh, for sorting?
Yeah.
So there's a Data tab at the top.
Yeah.
If you click on data, it'll have a sort.
Okay.
You
Little
click
box.
on sort, and it should automatically default from smallest to largest. So you click on that,
Okay.
and then it'll sort it automatically for you.
Oh my gosh, you're a genius. Yeah.
I know. Look at that. Wow. That's awesome.
Should be easy.
I love it. Okay.
Mhm.
So did everybody get theirs?
Yeah, I'm just doing number 6 now.
Oh, okay. Sorry.
No, it's fine.
Mine looks pretty close to the line. All of them.
Mhm.
Is yours too,
Yes, 3 and
Raquel? Okay.
Mine is.
Oh, good.
Yep, mine are close to the line as well.
Okay, so each of the samples are approximately normal based on what you see in the QQ plots. True or false?
True.
True. Okay. Question 12. If you perform an ANOVA test, you will observe that the p-value is 0.081. Remove the SOX data and perform the test again. What is the p-value when we remove the SOC data?
Okay, so that's when
Okay.
we remove variable 6.
Wait a minute.
So it's 0.309, right?
Where are we? Wait a minute. 0.081. Let me check this out. Oh, okay. Yeah, I see that. Okay, so we're removing the SOC data.
What did you get, Mackenzie?
I got 0.309.
Okay, that's what I got. Mhm.
Okay. What about you guys? Or Kathleen, are you still catching?
Yeah, that's what I got.
Okay.
The 0.309.
Crystal.
Yes, ma'am.
Cool.
Okay. We good?
Mm-hmm.
Question 13. The test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left of the F statistic?
It's always the right.
That's what I thought. Yeah, the right. Okay.
Mhm.
Okay. All right, the next one. Researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat, which is a whole bunch of stuff. For each of the 54 hot dogs analyzed, they recorded the type, calories, and sodium. Their data is available in the file, the hot dog nutrition thing. Use this data file to answer the remaining questions. So let's examine the calories, QQ plots. All right, so I guess we've put those in. Let's see.
Getting rid of sock data.
Yeah. So we're doing 4 rows, is that right?
Let's see.
Or is that 3?
3.
We
Yeah,
didn't-
3 rows. Beef, poultry, and meats.
Okay.
Ooh.
So
Are we doing
what is the
calories or are we doing sodium?
Well, let's see. It says, look, let's examine the calories first.
Okay, calories. Okay.
So calories first, it looks like.
Okay.
And we're supposed to do Q plots on them, right?
Yeah, that's what it says.
Okay. Yeah, I know.
Okay. All right, so what are we doing? Okay, so we have to do Q plots.
So like the first column, which is what beef. Beef
Uh-huh.
is normal. It's all along the line.
Okay, do you want me to do the 2? The second one? Or has anybody done that?
No yet.
I'll do the second.
And I'll do the 3rd.
Okay.
We're just doing calories first, right?
Mm-hmm.
Yes.
Okay, just making sure. Come on.
Ooh, mine's kind of a little off.
Mine's a little off too.
Mm.
Can I share my screen?
Even when you sort
Yeah.
data?
Well, wait, that's not right. There's one that's out of, wait a minute. There we go. Well, and I don't know how to share my screen, guys.
You just go to the side, but I'm sharing mine at the moment. So can you guys see mine?
Wait a minute.
Yeah, I can see yours, Mackenzie. You did number 3, or
Yeah, I
yours
did the
number
3rd
3?
one.
Okay. And on number 2 is kind of the same way. I looked at all 3.
Yeah, the 2 looks the same.
I think they're normal.
Yeah. Okay.
They look close.
So it says, okay, so on question 14, it's the first one is the assumptions have been met. It's safe to assume each group comes from a normally distributed population from the QQ plots, and we can assume that all variances are equal. Number 2 is the assumptions have not been met. While it is safe to assume each group comes from a normally distributed population, we cannot assume the variances are equal. 3, the assumptions have not been met. It is not safe to assume each group comes from a normally distributed population, but we can assume the variances are equal. Or the assumptions have not been met. It is not safe to assume each group comes from a normally distributed population, and we cannot assume that the variances are equal.
I wouldn't say they're equal. I would, because on number 2 it kind of goes out, and so does it on number 3.
Mm-hmm.
So I don't know that I would say they're equal.
The variances
What
are
do you
equal.
think, Raquel?
I think they're equal. Like when you show, like McKinsey showed the QQ plot, I didn't see like that big spreading.
Yeah.
It's just like a small curve,
Yeah, it's a curve.
the line. And
Yes.
I've seen those.
How big does it have to be on the outside for it to not be?
I don't know for sure.
I think they have to be like very, very spread. Like
Scattered.
uh-huh.
The goal is they have to be met and they have to be equal, right? So
Mm-hmm.
Yeah.
I don't know.
Well,
I think it's either 1 or 3.
Let me see 3. Assumptions have not been
What did you guys get for number 10? Obviously, I didn't put it down.
No,
It's true, right?
Yeah,
it's true. Yeah.
Okay, good.
Well, we could always just agree on one and then see what we get. I
don't know.
Let me.
The first or the third.
So it says this, the QQ plot roughly follows a straight line. That's what the review says.
Mhm.
That it's satisfied when the QQ plots for the data in each group roughly follow a straight line.
I guess they roughly follow the straight line.
Roughly. Hang on, I know I printed out some stuff. Oh, wait a minute. Oh no, I think that's on something different. Okay, well, what do you guys think? We cannot assume that the variances are equal. So the largest variance is not more than 4 times the smaller variance. That's how we determine that, right?
But
So what did you guys get on the variances? Did you put them into the ANOVA thing?
Yeah.
oh, I haven't. Yeah. Mhm.
I'm wondering if I got too many on this one. What's the first variance you guys got for variable 1?
512,661.
Okay, that's right then. Okay, so the smallest is 508.
Mhm.
The biggest is 636, and that's not
Yeah.
even 1 times. So
Mhm.
that would be true then. The variance would be
Equal.
equal. Uh-huh.
Yeah, I think it's the first one. I think they are normally like.
Let's try it. I agree with you. But it says we cannot assume that the variances are equal. But aren't they? Can't we assume they're equal if it fulfills the largest variance is not more than 4 times the smallest?
Come again? I didn't understand. Like.
Oh, I think I was looking at the wrong one. Oh, okay. Did you say number 1? I'm sorry. I was looking at number 2.
Okay, okay.
I agree with number one.
Not. Yeah.
Yeah.
You guys agree?
I would say it's safe to assume, yeah. I would say number 1.
Okay. All right.
Yeah.
15. So run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51, that F equals 16.04, and that P equals 0.000 with a level of significance equal to 0.05. What conclusion can you draw? Degrees of freedom are 2 and 51. $16.074. 074. Okay.
Hey guys, I'm freezing, so I put them on. Dang. Cold.
Why is P 0.000?
Because we had an exponent
Oh,
-0.06. So when you convert it to decimal,
oh. Then it would be 0.000?
like 5
Okay.
or 3.
Okay.
Mhm.
58. So what are we trying to find then?
Just the
Yes.
conclusion.
Okay, so the p-value. Okay, so we have sufficient evidence to claim that all 3 hot dog types have the same mean of calories. We do not have sufficient evidence to reject the claim that all 3 hot dog types have the same mean number of calories. We have sufficient evidence that all 3 hot dog types have a different mean number of calories, and we have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than any other type.
I think it's the last one.
I would agree.
So we're comparing, are we comparing the p-value
Yes.
with the level of significance? Okay, I think that's right because that kind of goes with the ANOVA definition, right?
Yep.
Okay. You ready for 16?
Yep.
Yes.
Okay, now let's examine the sodium levels. Construct QQ plots for the sodium of each type of hot dog. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 7180.75 and the largest is 10492.871. Have the assumptions been met to use ANOVA? So I guess, do we all want to? I'm going to
I'll do beef.
clear these.
Do we want to split them up again?
Yeah, I can do the first one unless someone's already doing it.
Yeah, I said I'll do beef.
Oh, beef. Beef. Okay, is that the first one? Okay, I'll do meat.
Okay, I can do the next one. It's, I don't, poultry.
The poultry.
Uh-huh.
Mhm.
Ooh. Okay. So the first one has a little guy outline out there.
Let's see.
Do you care to share your screen?
You see that one, Mackenzie?
Do you care to share your screen?
Oh, yeah, I can. I'm actually doing it on 2 different.
Oh, you're multitasking.
One computer works for specific things, and another works for totally different things. So,
Let's get you a computer.
well, it's like my husband has this one. Well,
Yeah.
I do another one.
But still, that's hard.
Mine looks pretty normal, the one that I did.
Okay.
Yeah, portrait looks normal, I think.
Mine looks okay. It's a little off, like in the middle.
Do you have yours?
Yeah, I can
Do you
share
see
it.
the one that's way down at the bottom, Mackenzie?
Yeah. Wait, I can't see it. Are you talking about on your screen?
Well, I have it on my other one, but if you pull it up, hold on, I'll show you in just a second.
That's okay.
It's loading. Okay.
Mackenzie, did you get the first one?
Yeah.
Okay.
Okay, so maybe it'll load now.
That's what mine looks like, if you guys can see that.
Can we see yours, Mackenzie? Is that what you're doing? Yeah, so see there's that one that's way down there.
Yeah.
Could you share?
Outline.
Where's my new one? Oh, there, that one was. What in the heck? Oh my gosh, I don't know what is going on with this.
Are you doing the history?
Yeah, I'm trying to do the Nova thing. Are you guys there? Have you done it?
What? Which one?
Oh, have you guys inputted your stuff into the ANOVA?
Oh.
No. Nope.
Oh. Oh, sorry.
No.
I don't know why I'm having a issue with these here. I don't know what the deal is, but
I will do it real quick. Come on, paste. Oh.
I'm having a hard time with mine. I don't know why it's doing that. It's doing some weird things.
Excel is no fun.
Mm.
That's why I've decided is no fun.
Mm.
Kathleen, yours is meat, right?
Mine was the second. Is that what that is? Yeah. Uh-huh. Oops. Why is this not working? Clear it. It's not clearing. Oh, there it is. Okay.
So
right.
from what I see, I have all different variances.
Yeah. The lowest is 7180 and the top is 10492. I think that's what they said. Oh, yeah, yeah. So we have to have the assumptions been met. So are you guys there yet? Are you ready?
I think it's the second one on 16, question 16.
Okay. So the first one is the assumptions have been met. It's okay to assume that each group comes from a normally distributed population from the QQ plots. And we can assume that the variances are equal. The second is the assumptions have not been met. While it is safe to assume each group comes from a normally distributed population, we cannot assume the variances are equal. The third is assumptions have not been met. We can't assume each group comes from a normally distributed population, but we can assume that the variances are equal, or the assumptions have not been met. It's not safe to assume that it's from a normally distributed population, and we can't assume the variances are equal. Well, the variances are equal, aren't they? Because the largest is 10492 and the smallest is 7180.
Mm-hmm.
So the largest variance is not more than 4 times the smallest.
Mm-hmm.
So that's been met.
Okay.
That's what I understand it to mean.
Yeah,
Yeah.
you're right.
And then what about my QQ plot looked normal. I mean, it was off a little bit.
Mm-hmm. Mine too. I think it was normal.
What do you guys think?
I would say it's the first one again.
Yeah.
Okay, I'll agree with you.
Number 1.
Huh?
Yep, 1.
Yep. Okay. Are we ready for 17?
Wait, what about Crystal?
Crystal, where are you?
I'm here.
There? Oh, there she is. Okay.
I'm
You
here.
running ahead on us.
No, I don't know that I agree with that one, but I'm just gonna say okay.
Ah,
What do you think? What do you think it is?
Let us know.
Oh,
what do you think?
I'm confused on that one. I don't know.
Because the plot lines kind of look funky, huh?
Yeah, but that always throws me off. I guess I take things probably too literally. I'm like, it's got one off, it's not equal, but you guys are probably
Right.
better than I am.
No, it's okay. Like, just tell us what you think.
I would say I don't know. I don't know.
Well, I guess if we
I
go,
thought it was the third one.
See, I'll go with number 1 because Raquel said it was the number 1.
What did you think? It
Raquel is usually right about these things.
That is 1,000% true.
All right,
Okay.
let's go to 17.
Okay.
Okay, 17. Despite the possible problem with the QQ plot for poultry. Uh-oh.
What?
Maybe that's what it means. Because it said the possible problem with the QQ plot for poultry.
But that was
What-
mine. Let me
What
check.
did poultry look like?
Mhm. Let's see. Let's see.
So maybe it wasn't normally distributed.
That poultry.
That poultry.
So should we change our answer to 3?
Let's see again. Poultry.
The mean sodium levels are the same. You decide to use determine the mean. What is the P?
Mm. Maybe we should change the answer then.
Yeah? Okay. To number 3?
Yeah. What do you think?
Well, we can try it.
Wait, sorry guys. Were we thinking number 3 for 16?
Yeah.
Hmm.
Because the 17 says despite the problem with the QQ plot for poultry. So,
Okay.
Oh, sorry.
Let's test it out and see.
okay.
But for
So,
oh, sorry, go ahead.
no, so question 17 is the p-value.
Yeah. Did anyone get 0.179?
Yes. That's what I got.
That's what I will put.
Okay, and then 18. What conclusion can you draw about the mean sodium levels of the 3 types of hot dogs? Use a level.
Sorry.
Huh?
I got kind. What did you get in 17?
Oh, sorry. 0.179.
1.179.
So,
Okay. Uh-huh. Sorry.
okay, that's okay. So 18's asking what conclusion can we draw about the mean sodium levels with a level of significance of 0.05. So it's higher than that. So the first one is we have sufficient evidence to claim that all 3 hot dog types have the same mean sodium levels. 2, we do not have sufficient evidence to reject the claim that all 3 hot dog types have the same sodium levels. 3, we have sufficient evidence to claim that all 3 hot dog types have a different mean sodium level, or we have sufficient evidence to claim that at least one of the hot dog types has a different mean.
There isn't a specific rule to this, is there? Look, I'm just being cautious.
No, I know.
Ugh, it's so hard.
It gets confusing, doesn't it?
Yeah.
It just changes each week. It's like, but this is okay, and then this is not. I think it's the second one.
Yes, it is the second one.
Okay.
Because we can.
Crystal, do you agree?
Yeah,
Crystal?
we.
So it's higher.
Don't take what I'm saying.
No, if it's less than, then we reject,
Mm-hmm.
right?
Right.
If it's higher, we
failed to reject.
fail to reject.
Mm-hmm.
Oh shoot, what happened to my thing?
So every time we fail to reject, that means that we do not have sufficient evidence.
Right. I think you're right with that.
I get what you're saying. Okay.
Okay. All right. I'm gonna submit, guys. I'll be the guinea pig.
100%, y'all.
Really?
No. What? I'm sorry. I'm in complete shock. The last 5 times that we did it, we got him like so many wrong.
Hallelujah.
Holy freaking Luya.
What's happening?
Oh my
I'm
gosh.
so happy. Yay!
Okay. I'm so dumb, you guys. You know what I did?
What did you
The first question, I missed it.
Oh,
no.
Instead of true. I am so dingy, you guys.
yeah.
Oh my gosh. Now I got to do it all over again.
Well,
Look
I
how
think
dumb.
we're just so used to doing it a second time, you had to do something to make.
I know. Oh, that's so dumb. Okay, hang on, guys. I got to write this down. Do you want to get ready for the 15? We're doing the quiz, right?
Yeah, but that's like the review of everything for the past 3 or 4 weeks. So I don't know.
I think
Do we
I
want?
thought we were supposed to do it together.
We
Didn't
are.
we?
Yes,
We are.
Oh,
But-
okay.
I
but
think
do we
Mackenzie,
wanna
what
jump-
Mackenzie's saying is, do we want to wait?
Yeah.
Like,
Like,
when?
Oh,
Practice, or do we want to jump into it? I don't know.
I don't know. I was planning on doing it, but
We can do it after she posts like the review.
okay, but then we have to
Ready?
meet again though, right?
Yeah. Did she say on Wednesday?
Yeah, on
Okay.
Wednesday.
Because she's sick. And then the test is due this weekend, so we have until Saturday to do it,
Yeah, true.
which is awesome.
Mhm.
I just know our last time it took us like
It was a long time. Yeah.
Yeah.
Okay. I think. So what are you guys thinking? Thursday?
I cannot do
So-
Thursday because I have to work in the evening.
I think I might be on call on Wednesday.
Oh, okay.
And if I get called out, then I probably can't be here.
Mm.
what
But
if
we
we did it early on Wednesday instead of
Well, when I'm on call from 5 to 8. So, what basically that means is if I need to do an admit for someone, get them admitted to hospice, that means it could be later in the afternoon, like 4 or 5 o'clock. And then it usually takes me like 4 hours or so to do it all. But we can shoot for, why don't we shoot for like 7:30? Can you guys do that on Wednesday or 8?
Yeah.
What would work for you guys?
I'm good. Any of those times.
Yeah, any of those times.
Mhm.
What's easier for you,
How
Kathleen?
about 8 o'clock?
Okay, Yeah.
Will that work on Wednesday night?
that works for me.
Okay. Whose turn is it to call? Is it mine?
It's my turn.
You don't have to record that one though. Just letting you know.
Oh, yes.
Oh, the review we don't?
Last time and I recorded it and then I was like, where do I post it? And she goes, you don't post it. I'm like, oh,
Oh, okay, cool.
so you don't have to record that one.
Cool.
Cool. Okay. Awesome.
So it doesn't have to post it?
Nope, we don't have to post it.
Oh, okay. Okay.
Yeah.
Mm-hmm.
Okay, well, I'll plan on seeing you guys Thursday at 8 o'clock then.